Bioactive compounds are mostly secondary metabolites produced by plants to subsidiary pathways. They are extra nutritional constituents that are found in small quantities in foods, providing health benefits beyond the basic nutritional value of the product. These health benefits include antioxidant, anti-carcinogenic, anti-inflammatory, and antimicrobial properties. Bioactive compounds can be excessively found in foods such as fruits, vegetables, and grains. Although bioactive compounds are naturally present in various foods, they are being used as additives in the food industry. For instance, they are being used as antioxidants to prevent oxidative damage to increase shelf life of the product. Not only that, bioactive compounds are used as a flavoring agent. They provide a better alternative for synthetic aroma compounds as they provide a lot of health benefits. One example is where vanillin is used in the production of sweet fruits, chewing gums, and beverages. Last but not least, they are also used as an alternative colorant for synthetic dyes. Some common coloring bioactive compounds include carotenoids, anthocyanins, and curcumin. Bioactive compounds include an extremely heterogeneous class of compounds with different chemical structures and distribution in nature. However, they can be classed into three major classes, which are alkaloids, terpenoids, and phenolic compounds. Bioactive compounds are produced by plant cells through metabolic pathways. These three classes are synthesized by four major pathways, which are the shikimic acid pathway, malonic acid pathway, mevalonic acid pathway, and MEP pathway. Now, let's take a look at the classes. Alkaloids are organic compounds characterized by a nitrogen atom in a heterocyclic ring. In addition to carbon, hydrogen, and nitrogen, they may also contain oxygen, sulfur, and other elements. Examples of that can be seen in the structure of quinine and caffeine, where they contain oxygen molecules. Other examples of alkaloids also include nicotine, piperine, and theobromine. Terpenoids are derived chemically from 5-carbon isoprene units assembled in different ways. They are classified according to the number of isoprene units in the molecules, and this is the general formula. Some examples of terpenoids include essential oil, diterpenoids, triterpenoids, and carotenoids. Phenolic compounds are the substances containing benzoic molecules with one or several hydroxy groups as their derivatives. Phenolics can be classified according to their structure or biosynthetic origin. They are generally classed as phenolic acids, phenylpropanoids, tannins, quinones, and flavonoids. Firstly, we have phenolic acids and phenylpropanoids. Phenolic acids are derivatives of benzoic and cinnamic acids such as vanillic acid, ferulic acid, and caffeic acid. On the other hand, phenylpropanoids are naturally occurring phenolic compounds which have an aromatic ring that are derived from the amino acid phenylalanine to which a 3-carbon side chain is attached. Both phenolic acids and phenylpropanoids can be found in cereals, legumes, fruits, and vegetables. Moving on, tannins are polyphenols which have the ability to precipitate protein. They have the ability to react with protein to form stable water-insoluble copolymers. They have been used to convert raw animal hides into leather. Next, quinones are aromatic compounds whose carbonyl groups can either be 1,2 or 1,4 to each other. They are natural pigments ranging from pale yellow to almost black color and are frequently present in bark, hardwood, root, or leaf tissues. Lastly, we have flavonoids. From the diagram here, we can see that the general structure of flavonoid is a 15-carbon skeleton containing 2 benzene rings connected by a 3-carbon linking chain. Flavonoids may be divided into various classes according to the oxidation level of the central ring. Common classes include flavon, flavonols, and anthocyanidin. Phenolic compounds are highly valuable to human nutrition as they contain antioxidants and anti-proliferative properties. Studies suggest that a high dietary intake of polyphenols is associated with a decreased risk of cardiovascular and cancer diseases. One of the phenolic compounds that exhibits high antioxidant activities are flavonoids.
Okay, thank you, Janavi, for the wonderful explanation on bioactive compounds. Now I would like to explain a group of bioactive compounds, which is flavonoids. Okay, I would like to introduce flavonoids. Flavonoids is a group of natural substances with variable phenolic structures. It is the most substantial group of phenolic compounds in the human diet. Besides that, it has several types, which are flavones, flavonols, flavonols, flavonones, isoflavones, and anthocyanins. Moreover, it can be found in several sources such as fruits, vegetables, grains, bark, roots, stems, honey, flowers, tea, and wine. Actually, there's plenty more of the sources for flavonoids, but I don't want to put it all in here because it will drag our time. For the basic structure of flavonoids, why it is basic? Because flavonoids has a lot of types. So this is the most basic structure for flavonoids. It is derived from the parent substance flavone, and as Jahnavi mentioned earlier, that flavonoids is composed of 15 carbon skeleton. But what makes it different from other bioactive compounds are it consists of two phenyl rings, A and B, as you can see from the picture, and heterocyclic ring, C, that one, the one that consists of oxygen. Actually, phenyl rings are just benzene, but they act as the substituent for this compound. So that's why the name is phenyl. Okay, now let's move on to the chemical and physical properties of flavonoids. First of all, it is a secondary metabolite in plants that show some desirable characteristics. Besides that, it is a group of pigments that may exhibit a lot of beautiful colors. Moreover, it can exhibit a lot of health benefits such as antioxidant, anti-inflammatory, anti-cancer, and so on. Furthermore, it can inhibit the microbial growth, so it is safe to assume that it can act as preservative. Last but not least, as I mentioned earlier, it is a pigment, so it can exhibit colors. It may exhibit yellow, scarlet, red, purple, violet, purple, blue, and so on. Because flavonoids has a lot of types, so they can exhibit a lot of color. If you can recall back what I have said earlier during this presentation, that it has been reported that flavonoids are substantial for human health. Why? This is because of their health benefits. First and foremost, it has antioxidant properties, and because they act as free radical scavengers, as they are potential reducing agents that protect from oxidative damage, which are conferred by the content of hydroxyl groups. Besides that, it has antibacterial, antiviral, and anti-inflammatory activities. In recent years, flavonoids have been investigated based on their ability to reduce the incidence of many diseases, to inhibit cell damage, to repair DNA process, and to reduce oxidative stress. Besides, flavonoids have been demonstrated to have cardioprotective effects, which means they can protect us from cardiovascular diseases. Besides, flavonoids have potential to improve coronary vasodilation and prevent LDLs from oxidizing, and also show potential neuroprotective effect. Due to the benefits that flavonoids have to offer, flavonoids have been used widely in the food industry. Why? First and foremost, this is due to their ability to preserve foods. As I mentioned earlier, that uh, flavonoids have the antimicrobial activities, so it is very suitable to use flavonoids as a preservative. Besides that, it can provide flavor, which is astringency and bitterness. Okay, next, it can be used as dietary supplements and supplement for animal feeds. Last but not least, it is a natural colorant. Why? Flavonoids is a secondary metabolite of plants, so we can extract flavonoids from plant and then use it as colorant. That's all from me. I will like to pass this presentation to Arkan.
Next, we are going to run an flavonoid identification process in honey. Identification is done by using HPLC analysis. And an HP analysis stands for High Performance Liquid Chromatography. An HPLC analysis run a chemical analysis that require component separation and identification of a mixture. HPLC is a qualitative method that runs on pump to pass pressurized solvent containing the sample mixture to a column that is filled with a solid absorbent material. Thus, the interaction between the solvent and its adsorbent material causes a different flow rate, creating a separation of the components as they flow out of the column. The material and apparatus that is used in this experiment are honey, HCl solution, cotton, distilled water, methanol, formic acid, TLC, and toluene, while the apparatus that is applied are HPLC device and a column of 25 by 2 of amberlite XAD number 2. The initial process of HPLC analysis starts from sample extraction and preparation. The sample is mixed with acid and filtered. The filtrate is passed through a column, and the filtration will separate polar compounds with the aqueous solvent. The column is then washed, and the concentrated remain of the phenolic compound is then pressurized for purification by methanol inside a column. The flavonoids were then concentrated under reduced pressure, redissolved in methanol, and ready to be analyzed by HPLC. The analysis is done on a reversed phase column using methanol as a solvent. Sample of 5 ml of methanol solution of flavonoid were then injected. Flavonoid identification. The HPLC analysis will show a different flavonoid present in the sample as it is bulked and separated by preparative column chromatography. The fraction obtained were then purified by preparative TLC, and the different substances were then identified by UV spectrophotometry. To determine the flavonoid present in honey, we have to isolate the compound from high amount of sugar and produce a purified flavonoid. The use of amberlite XAD2 column allows the elimination of sugar and polar compounds. Further purification through Cefadex LH20 is required to exclusively isolate flavonoid compound for further analysis. After we have isolated the flavonoid present in La Alcaria honey and identified them by using UV spectrophotometry in methanol solution, 16 flavonoid aglycons were identified in figure number 1. The research finding shows that flavonoid present in pollen is glycoside, while aglycosin or hydroxylated glycans is found in honey. This finding suggested that part of the flavonoid found in honey have originated from pollen. Thus, the presence of aglycans is a result of glycoside that has been hydrolyzed by bee saliva. The detection of flavonoid compound using HPLC is used as a biochemical marker on the plant origin of bee pollen. Aglycone found in honey provide various health benefits to our body. Aglycone act as an anti-obesity and anti-diabetes activity through improved lipogenesis, hyperlipidemia, hyperglycemia, and insulin resistance. Glycoside flavonoid found in honey is enzymatically hydrolyzed by beta-glucoside inside our intestine. I think that's all for our presentation for today, and please like and subscribe to the video. Thank you.